Good morning, everybody. Today we are going to solve October, November 2013 1-2 paper. Course is Physics 5054 and it's an MCQ paper. On your screen, you can see question number 1. Let me adjust it. Yeah. A length of copper pipe of uniform cross section and several meters long carries water to a tap. Measurements are taken to determine accurately the volume of copper in the pipe. Which instruments are used? See, if you want to find out the volume of this pipe, we need to find out the internal volume of this pipe. We need to measure the length of the pipe, and we also need to measure the external diameter. We also need to measure the internal diameter. Because the pipe is several meters long, so it will be better to use a tape for length, and for internal diameter and for external diameter we will use vernier caliper. So the choice looks D, tape and the calipers. For question number 1, the choice is D. For question number 1, the choice is D. Okay, on your screen you can see question number 2. An object moves from P to Q in 10 seconds with uniform acceleration. Velocity of the P is 5 meters per second and velocity at Q is 12 meters per second. What is the acceleration? You know the acceleration, the formula for the acceleration is change in velocity divided by time. V minus U divided by time. So 12 minus 5 divided by time. So 12 minus 5, it will give you the change in velocity, that is 7 meters per second. The time is 10 seconds, so divide the 7 meters per second with 10 seconds and you will get the answer 0.7 meters per second. So the acceleration is 0.7 meters per second square. So the choice is B. Question number 2, the choice is B. I have also done this on a paper. Let me show you. Okay. On your screen, question number 2, you can see, first of all, we calculated the change in velocity. That's 12 minus 5, and the answer was 7 meters per second. Then we know the time taken is 10 seconds. The formula for the acceleration is change in velocity divided by time. So 7 meters per second divided by 10 seconds, the answer is 0.7 meters per second square. I hope that this is clear to you. Okay, so the next question on your screen is question number 3. The graph shows how the height of an object above the ground changes with time. What is the terminal velocity? The graph given here is the distance time graph. On the x-axis, time is represented in seconds, and on the y-axis, the height is given, which is distance in meters. You know the slope of the distance time graph represents the velocity. The slope, the gradient represents the velocity. Now, he wants us to find out what is the terminal velocity. Terminal velocity means that the body will be moving with a constant velocity. So how I know the body is moving with the constant velocity, the distance time graph will become a straight line, inclined straight line. That will tell me that the body is moving with a constant velocity, because the slope of the distance time graph is equals to velocity or speed. So look at the graph and see where here you can see after 1 second till 2.5 seconds, the graph is an inclined straight line. It means its gradient is constant throughout. From 1 to 2.5 seconds, the gradient is constant. That means the body, and the gradient here represents the speed. So it means the body is moving with the constant speed. So it means that it has reached the terminal velocity. If I want to find out the gradient of, if I want to find out the terminal velocity, I need to find out the gradient of this straight line. So just take 2 points on that straight line, note down their coordinates. For example, let's say I take this point Its coordinates are 1, 3. The x value is 1, the y value is 3. Let's say I take this point, its coordinates will be 2.5, 0. And then apply the formula for the gradient. You must have studied in your mathematics that the gradient of a straight line can be found by y2 minus y1 by x2 minus x1. So apply that formula and you will be able to find out the slope, and that slope will be the terminal velocity. I have done this. Let me show you my work. Okay, let's say at the points I have noted down, they are 1, 3 and 2, 1. Then applied the formula for the slope, that is y2 minus y1 by x2 minus x1. 1 minus 3 divided by 2 minus 1 minus 2 by 1. So the answer is minus 2 meter per second. It means the speed is 2 meter per second. The terminal velocity is 2 meter per second. The option is D. The option is D. I hope this is clear to you. Okay, on your screen now we have question number 4. A sphere of mass 80 kg accelerates down a slope at 2 meter per second square. The gravitational field strength G is 10 Newton per kg. What is the weight of the sphere and the resultant force on the sphere? It's very easy. You know, if you know the mass, you can find the weight. The weight is equals to mg. W equals to mg. The m here is 80 kg and the value of the g is 10 Newton per kg. So the answer will be 800 Newton. If you want to find out the resultant force and you know the acceleration and the mass, you can use the Newton's second law of motion, whose mathematical equation is F equals to ma. F is the resultant force we want to find out. M is the mass, which is 80 kg, and A is the acceleration, which is given in the question, 2 meter per second square. So just multiply. The answer will be 80 multiplied 2. It will be 160 Newton. I have done this also on a paper. Let me show you that work. You see, question number 4, C part is on your screen. W is equals to mg. W is equals to 80 into 10, and 800 Newton will be the weight. Resultant force will be F is equals to ma. 80 into 2 and 160 Newton. So the choice is C. Choice is C. I hope this is clear to you. We are moving to next question. A famous question which repeats many times in papers. Question number 5. The diagram shows an aeroplane turning in a horizontal circle at constant speed. In which direction is there a resultant force? You know, I have told you many times that whenever you move in a circular path, the direction of the resultant force is always towards the center of that circle. The direction of the acceleration is also towards the center of the circle. But here the question is, what is the direction of the resultant force? That will be towards the center of the circle in which you are turning. So if you look at that figure, so the circle, the option D is pointing towards the center of that circle in which you are turning. So D is the option. Resultant force is in the direction of D. Question number 6 is on your screen. The weight of cylinder on the moon is less than its weight on the earth. How do the gravitational field strength and the mass of the cylinder on the moon compares with their values on the earth? Because the weight is less on the moon of an object as compared to its weight on the earth. This is because the gravitational field strength of the moon is less than the gravitational field strength of the earth. And the mass, you know, whether you measure it on the moon or whether you measure it on the earth, the mass does not depend upon the location. It does not depend upon the gravitational field strength. So the moon, at the moon, the mass of the object will be the same as the mass was on the earth. So the option looks to me C. Question number 6, the option is C. I hope you have understood. Okay. On your screen, he says two stretch springs X and Y are attached to one end of a meter rule as shown. A weight W is hung from the other end. A pivot is at the center of the rule. The weight W is moved towards the pivot. How does the extension of the each spring changes? Try to understand this. You see, right now, this whole thing is in equilibrium. Anti-clockwise moment produced by this weight is equals to the moment produced here, the clockwise and the clockwise moment produced here. The anti-clockwise moment produced here and the clockwise moment produced here, they are equal. That's why the whole thing is in equilibrium. But if you will move this weight towards the pivot, the anti-clockwise moment will decrease. The clockwise moment still will be the same. But because you have moved this weight towards the pivot, its moment arm has decreased. So its moment, the anti-clockwise moment will decrease. This whole thing will be no more in equilibrium, because now the clockwise moment will be larger. This meter rule will move, it will rotate, it will tilt, it will move in a clockwise manner, because the anti-clockwise moment is now less and the clockwise moment is larger. So what will happen? This rod on the right side of the pivot, it will go down. The meter rule on the left side of the pivot will go up. When it will on the right side of the pivot, the meter rule will go down. It is moving in the clockwise manner. This X will compress and the Y will compress and the X will stretch. Let us look at the options. So the length of the spring, the extension of the spring, Y will decrease and the extension of the spring X will increase. So C looks the option. When this will move down, this will move up, its extension will decrease and its X extension will increase. So for question number 7, C is the option. I hope that it is clear to you. This story, this question, whole scenario is clear to you. So C is the option, sir. Okay, so we are moving to the next question on your screen. Question number 8. A piece of uniform card is suspended freely from a horizontal pin. Which pin is its center of mass? So the center of mass should be where? So if you look at here, it looks to me that C should be the center of the mass, because here the mass is larger. So it cannot be B, because here the mass is smaller, here the mass is larger. So here the center of mass should be on the point C. So for 8, question number option is C. On your screen we have question number 9. An extension load graph is plotted to show the result of increasing the load on a spring. Which point makes the limit of proportionality for this spring? This is an extension load graph. and the extension load graph until the graph's gradient remain constant. It is in the limit of proportionality. But if the graph starts curving, it means that extension and load is no more directly proportional to each other. So when the shape of the graph starts curving, it means that the limit of proportionality has been crossed. So till the point B on your screen, till the point B, the graph is a straight line. After the point B, the graph started curving upward. So it means that the B is the limit of proportionality. So B is the limit of proportionality. Question number 9, B is the option. Okay, on your screen, you can see the question number 10. Two vessels S and T are filled to the same level with the same liquid. The area of the base of S is less than that of T. Which statement is correct? Remember one thing, we have liquid in both the vessels, and the pressure of the liquid do not depend upon the area of the vessel. It do not depend upon the shape of the vessel. The pressure of the liquid only depend upon three things: the vertical height of the liquid column, it depends upon the density of the liquid, and it depends upon the gravitational field strength on that location. Because the vertical height of the liquid in both the vessels is same, that's why the pressure of the liquid in both the beakers will be same at the base of the liquid. So the pressure on the base of S is the same as the pressure on the base of T. For question number 10, D is the option. I hope it is clear to you. Okay, we are moving to next question. On your screen, you can see question number 11. 4 different liquids are poured into identical measuring cylinders. The diagram shows the depth of liquids and their densities. Which liquid causes the largest pressure on the base of its measuring cylinder? You know, in each diagram, we have different liquid. In each cylinder, we have different liquid. Each liquid has its own density, which is given. And we also know the depth of the liquid. And we can find out the pressure of each liquid. The formula for finding the pressure of a liquid is rho GH. Pressure of A will be rho GH, where rho stands for the density of the liquid, G is the gravitational field strength, and H is the vertical height of the column of the liquid. You know the vertical height, for example, in the A, cylinder A, the vertical height is 10 centimeter. The value of the density is 2 grams per cubic centimeter. The G value is 10 meter per second square. You know the units do not seem consistent, especially the unit of G, which is in Newton per kg. But because when I will be comparing the pressure of each cylinder, and each will have a G value in it, so the units of G does not matter here. So you can use 10 Newton per kg or 10 meter per second square. So the units will be not consistent. The units of the G are not consistent with the units of the density and the length and the height of the column. But because G value will be in all the calculations, so that's why when we will be comparing, the G value will not matter then. I have done this calculation on a paper. Let me show you that calculation. You see on your screen, the pressure of A, rho GH, 2 into 10 into 10 equals to 200. Pressure of B, 2 rho GH, 1.6 into 10 into 20 equals to 320. The pressure of C is rho GH equals to 1.2 into 10 into 30, 360. Pressure of the D is rho GH equals to 0.7 into 10 into 40 equals to 280. So the question was, which is exerting the largest pressure? So 360, C is the option. C is the option for question number 11. So C is the option, sir. I hope you have understood it. Okay, on your screen we have question number 12. The conditions at the bottom and at the surface of a lake are given in the table. At the bottom of the lake, the temperature is 10 degrees centigrade. The temperature at the surface of the lake is 10 degrees centigrade. Pressure at the bottom of the lake is 500 kilopascal, and the surface, the pressure is 100 kilopascal. A bubble of volume 1 centimeter cube forms at the bottom of the lake. What is the volume of the bubble as it reaches the surface? You know the bubble which is formed in the lake. Inside the bubble we have air, and that air, when it is in the bottom, that bubble, when it is in the bottom of the lake, and when the bubble comes at the surface of the lake, its volume changes, and the pressure of the air inside that bubble, that changes. The volume and the pressure of that air inside the bubble changes when it is in the bottom of the lake and when it is at the surface of the lake. And you know the temperature is not changing. So it means we are talking about the pressure and the volume of a gas while the temperature is not changing. And you remember that formula, the pressure of the gas is related with the volume of the gas if the temperature do not change. The famous formula P1V1 equals to P2V2. So let me say the bottom of the lake is P1V1. Is the situation 1. So we know the pressure, we know the volume, and we know the pressure 2. We want to find out the volume 2. On your screen, you can see 12, question number 12. I apply the formula P1V1 equals to P2V2. 500 into 1 equals to 100 into V2. V2 is question. So V2 will be 500 divided by 100, and it will be 5 centimeter cube. So D is the option. For question number 12, D is the option. For question number 12, D is the option, 5 centimeter cube. I hope that you have understood all the concept related to this numerical. Okay, so we are moving to the next question. Question number 13, sir, is on your screen. When exposed to light, a solar cell generates electrical energy. 2 solar cells of equal area are tested. Each cell is exposed to sunlight of different brightness for the same time. Which statement could apply to the more efficient cell? You see, before going into the options, if a solar cell is more efficient, it will be able to produce the same electric energy even when there is less brightness, even when there is lower brightness, it should be able to produce the same electric energy. We will say that that solar cell is more efficient. So for question number 13, D is the option. It generates the same electric energy from light of lower brightness. Question number 13, D is the option. You can read the other options as well. Okay, so we are moving to next question, which is question number 14, and it is on your screen. Let me reduce the size. Yeah, question number 14 is on your screen, everybody. The diagram shows the path of a diver after leaving a platform and before entering the water in a swimming pool. The gravitational potential energy of the diver is 0 when he is at the surface of the water. Which statement about the diver's energy along the path is correct? You know, here the law of conservation of energy is being observed. The total energy of this isolated system remains constant, although it may be changing from one form into the other. And in the middle somewhere, it may be present in both energy forms. but the total energy of the system will remain constant. For example, on the top position of his dive, it might have only the potential energy, gravitational potential energy. And when he's about to touch the water surface, he might have only the kinetic energy. And at point X, he will have some potential, gravitational potential energy and some kinetic energy, but the total energy will remain same. So which statement about the diverse energy along the path is correct? The sum of his potential, gravitational potential energy, kinetic energy is constant. This is law of conservation of energy. Question number 14, D is the option. Question number 14, D is the option. I hope you have understood. Okay, dear students, we are on question number 15. A saucepan is used to heat up some water. How is heat transferred through the aluminum pan and through the plastic handle? You know, the aluminum is a metal. So through the aluminum conduction, by the conduction, the heat is transferred from one side of the aluminum to the other side of the aluminum. The conduction in the metal takes place by two methods. By the vibration of the atoms, and another thing it has is the movement of its free electrons. Because it's a metal, it has free electrons. But in the plastic don't have free electrons. It's an insulator. So in the plastic, the heat is only transferred by the vibration of atoms. So his question is easily transferred to the aluminum pan by, I think, the movement of free electrons and the vibration of atoms. And heat is transferred through the plastic handle by the vibration of molecules only. So B looks like the correct option. So for question number 15, B is the right option. B is the right option, students. So I hope you have understood it. On your screen, you know, we have question number 16. A silver cup is filled with boiling water from a kettle. A man touches the outside surface of the cup and finds it is extremely hot. Why is the surface so hot? The surface is so hot because the silver is a metal, and silver is a very good conductor of heat. So the hot water inside, its heat is immediately conducted to the outer edge, the outer side of the silver cup. So because the silver is a good conductor of it, that's the reason when you touch the cup, it feels very hot. So question number 16, B is the option. Silver is a good conductor of heat. Okay, my dear students, question number 17 is on your screen. The temperature shown by a mercury in glass thermometer increases. Which of the following is constant? The density of the mercury, that is not possible because when you heat up, the volume of the mercury has changed, so density of the mercury has changed. The internal energy of the mercury, that has increased. When you heated it, it has increased. The mass of the mercury, yes, when you heat something, its mass cannot be changed. So the mass is one thing. When you're heating the mercury, the mass is not changing. So his question was, which of the following is the constant? The mass of the mercury is constant. The volume of the mercury, that definitely is not constant. So the C is the option. Question number 17, C is the option. Okay, on your screen, you can see question number 18. Different amounts of energy are supplied to copper blocks of different masses. Which block experiences the greatest potential change? So you see the mass of the block of copper is given, and the energy supplied to it is given. And we want to find out in which there will be a greater change of temperature. And you know, the if the change of temperature is involved, the relationship between the heat, the mass, the change in temperature, we have a formula. Heat is equals to mc delta theta. Heat is equals to mc delta theta. M is the mass of that copper block. C is the specific heat capacity of the copper, which we don't know here, but we don't need here, because all the blocks are made of the copper, so the value of C will be same in all of them. So if I don't know the value of the C, it does not matter. I will just keep the C as C. And delta theta will be the change in temperature. Basically, we are interested in finding the change in temperature. So take the M and the C to the other side. So delta theta will be equals to heat divided by C divided by M. So don't bother about the value of the C, we don't know, but because all the blocks are made of the copper, so in all of them the C value will be C, and so it does not matter. So we will be able to tell what is. I have done this on a paper. Let me show you that work. Okay. So on your screen you can see question number 18. So the change in temperature is equals to heat divided by C divided by M. So for the body A, 200 divided by C divided by 0.1, and the answer will be 200 divided by C. In the same way for B, I have done, the answer is 1000 divided by C. For the block C, I have done, and the answer is 1500 divided by C. And for D body or block, I have done the calculation, and the answer is 500 divided by C. So you see the C value is present in all of them. So actually we don't know what is the value of the C, but because it is present in all of them, so when I will be comparing them, so there will be no problem with the value of C. So the largest change is 2000 divided by C. So A is the option. Question number 18A is the option. It went little tricky because the C value was not given, but you need to understand that because the C value was involved in all the calculation, in all the 4 blocks, so when I will be comparing, so the factor of the C will be cancelled out. So sir, A is the option. Question number 18, I hope you have understood. On your screen you can see question number 19. A fixed mass of gas is kept at constant pressure. Its temperature is raised. What happens to the volume of the gas and to its molecules? You know, it is at constant pressure and its temperature is changing. And when you will keep the pressure constant and the temperature and the volume, they are directly proportional to each other. So you see when the temperature will rise, the volume will increase. Okay. So when you raise the temperature at a constant pressure, we are talking about a gas, okay? When you raise the temperature and the pressure is constant, the volume will change, the volume will increase, and the molecules will be moving faster, plus the distance between them, that will be larger. So question number 19, C is the option. Volume will increase and molecules move further apart. 19, answer is C. Volume will increase and the molecules move further apart. I hope you have understood this. Okay, dear students, we are moving to next question. Yeah, on your screen we have question number 20. Air is heated in a sealed container with constant volume. Why does the air pressure increases when the temperature increases? Now he's again talking about gas. But this time he has kept the volume constant. It means the volume cannot change. When the volume cannot change, the pressure and the temperature are directly proportional to each other. If you will increase the pressure of a fixed mass of a gas whose volume is constant, the pressure will increase. His question is, why does the air pressure increase when the temperature increases? Because the molecules are moving faster. So the collision frequency of the molecules with the walls of the container, their frequency of collision will increase. Plus, now because they are more energetic, when they collide with the wall, they exert more force. So that's why the pressure of the air or gas inside that container will increase. Question number 20. The air molecules bounce off the walls more frequently. C. Question number 20. C is the option. You understand? C is the option. The collision frequency with the walls has increased. That's why the pressure has increased. I gave you the full detail. Question number 20C is the option. I hope you understand. Now on your screen, we have question number 21. The more energetic molecules in a liquid may escape from its top surface. What is this process called? It's a famous process. We call it evaporation, where the molecules which have large kinetic energy or energy, they escape from the surface of the liquid. We call it evaporation. So D is the option. Question number 21, D is the option. Okay, students, on your screen, question number 22. The diagram shows a ball floating in a tank of water. Which diagram shows the movement of the ball as the wave passes? You know, the water waves are transverse waves. And in the transverse waves, the particles of the medium vibrate perpendicular to the direction of the propagation of the wave. So if the waves are going in this direction, the particle of the medium will be vibrating perpendicular to the direction of the wave. Okay? So if the waves are going to the right, the particle of the medium will be vibrating like this, perpendicular to the direction of the propagation of the sound of the wave. So because the water wave is going to the right, so the particle of the water should move up and down. So D is the option. Question number 22, D is the option because it's a transverse wave. I hope I have made my point clear. Okay, so D is the option for question number 22. We are moving to the next question. Next question on your screen, dear students, is 23rd. A ray of light from a laser passes into a semicircular glass block. What is shown at M? You see, here the light is traveling inside the glass block, which is optically dense medium. And here the light has emerged from the glass block and it has entered into air, which is optically rare medium. So when the light entered from this medium, which was dense, optically dense, into this optically dense medium, from one medium into another medium, the light has changed its path. The light has changed its path, no more going on its original path. It has deviated from its path. It has moved away from the normal. This is called refraction. This process is called refraction. So D is the option for question number 23. D is the option. I hope I have made this point clear. Okay, on your screen you can see question number 24 is on your screen. A ray of light strikes the surface of a glass block at an angle of incidence of 40 degrees. The refractive index of the glass is 1.8. What is the angle of refraction inside a glass block? You know, when you have studied the laws of refraction, you must have studied the Snell's law. it says that the ratio of the sine of the angle of incidence to the sine of angle of refraction, that ratio remains constant. That ratio between the sine of angle of incidence and sine of angle of refraction, that ratio is called refractive index. N equals to sine I divided sine R, where N is the refractive index. I have done this question on a paper. Let me show you that. Okay, on your screen you can see question number 24. N is equals to sine I by sine R. The value of this I is given. So I will put that value. The refractive index N value is also given 1.8. So sine 45 divided by sine R equals to 1.8. So R angle will be sine 45 divided by 1.8. Get that value and take sine inverse of this. You will get the answer 23.1. So A is the option. For question number 24, A is the option. We need scientific calculator to do this calculation. I hope you know how to find sine and how to find sine inverse on a calculator. So A is the option 23. A. Okay, sir. On your on your screen, we have question number 29. Two campers are woken up in the middle of the night by a thunderstorm. The tent is lit by a flash of lightning, and they hear the thunderclap 5 seconds later. The speed of the sound is 340 meters per second. How far away from the tent is the lightning? You know, they know the speed of light. Sorry, they know the speed of sound, which is given 340 meters per second. And they know, they can find out, and they have found out that it took 5 seconds for the thunder sound to reach them. So by applying the formula distance is equal to speed multiply time, they can tell that what is the distance of the thunder from them. So the 5 and 340 meters per second, just multiply them, you get that distance. I have done this on a paper. Let me show you. On your screen, question number 25 is showing speed is equal to, distance is equal to speed multiply time. So it will be 340 multiply 5, and the answer will be 1700 meters. So question number 25, C is the option. Okay. On your screen, we have question number 26. The sounds produced by two musical instruments are directed towards a microphone connected to an oscilloscope. The waveforms are produced on the screen as shown. The waveforms show that the sound produced have a different property. What is the property? Their amplitude is same. Their frequency is same. The only difference is that the basic shape of the waves, they are different from each other. And that basic shape is known as timbre. We also call it quality. So question number 26, C is the option. Their timbre or quality is different from each other. On your screen, we have question number 27. He says, which material is best for magnetic screening? Magnetic screening is that the magnetic lines cannot cross a boundary. So therefore, making that boundary, we always use a material which is magnetic material. For that purpose, we normally use iron. So for question number 27, B is the option, iron. Question number 28 is on your screen. He says an ammeter is used to measure the current in a 300 ohm resistor. The ammeter is shown below. What is the potential difference across the resistor? You see, the reading on the ammeter is 6 milliampere. Here it is written milliampere, which means 6 expo minus 3 ampere. 6 expo minus 3 ampere. We know the resistance. His question is, what is the potential difference? The potential difference, the formula is V equals to IR. Ohm's law. V equals to IR. We know the value of the I, we know the value of the R. Just multiply them, you will get the potential difference. I have done this on a paper. Let me show you. On your screen, you can see question number 28. V is equals to IR is equals to 6 x power minus 3 multiply 300. And the answer is 1.8 volt. 1.8 volt. So the B is the option for question number 28. B is the option, 1.8 volt. Okay, so we are moving to the next question. The diagram shows a circuit in which all the switches are open. Two switch positions gives a resistance of 6 ohm between X and Y. So how we can get the 6 ohm resistance from this? If you close S1 and S2, they both will be parallel to each other. 3 ohm, 3 ohm, their combined resistance can be found. It will be 1.5 ohm. You know how to find the combined resistance of two parallel resistors? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So 1 by R equivalent is equal to 1 by 3 plus 1 by 3. So 1 by R equivalent will be equals to 2 by 3. R equivalent will be equals to 3 by 2, which will be 1.5 ohm. So close switch S1 and S2, and their combined resistance will be 1.5. So that 1.5 will be in series with 4.5 ohm. And in series, how we get the combined resistance? Simply add them. So 1.5 plus 4.5 will be 6 ohm. So you don't need to close this. So you see, S1 and S2 are closed and S3 is kept open. So for question number 29, to get a total resistance of 6 ohm out of this circuit, S1 and S2 need to be closed and S3 will remain open. So B looks the option. Question number 29, B is the option. I hope that it is clear to you. Okay, on your screen you can see, I hope, question number 30. On your screen, question number 30, which is the current voltage IV graph of a filament lamp. Remember, in the filament lamp, as the voltage increases, the resistance of the filament lamp also increases. Here, the graph, the 4 graphs which they have shown, in them the I is on the y-axis and V is on the x-axis. If you will take the slope of these graphs, that will be I divided by V. The slope of these graphs is equals to 1 by R. The slope of these graphs is reciprocal, or we call it reciprocal of the resistance. So whatever will be happening to the slope, the opposite will be happening to the resistance. And I told you in the start that in the filament lamp, as you increase the voltage, the resistance of the filament lamp increases. It means that the slope should decrease. So as the voltage increases, the slope should decrease. And this is happening not in the B, not in the C, and not in the D. Yes, it happened a little bit, not to that good. The actual diagram, which is a textbook diagram, is the A, in which the slope has gradually started decreasing. So A is the option. For some time, for some values of voltage, the R remained constant and then started decreasing. the value of the slope started decreasing, it means the value of the R has started increasing. So A is the option for question number 30. A is the option. I hope you have seen this graph in your textbooks with wherever you study filament lamp. Okay, everybody, question number on your screen is 31. The diagram shows a circuit containing 5 resistors connected to a battery in which resistor is the current the smallest. You know, it does not involve calculation. It is just a conceptual question. Here, from the positive terminal of the battery, the current will come out, and the same amount of current will go back to the battery. So when this from the positive terminal the current comes out, the whole amount of the current passes through A. And at this junction, the current will be divided. Some current will flow through B and some current will flow through C. Because here they are in parallel, so current find two paths. The current will be divided. The current will be larger in that branch where the resistance is low, and the current will be smaller in that branch where the resistance will be larger. So very small amount of current will flow through C and a large amount of current will flow through B. And then the whole current will join again with each other, and then the current will be again divided. But this time, you know, again we have two resistors which are parallel to each other, but the value is same. The resistance value is same. So current will be equally divided. But on this parallel combination, the current is not equally divided. So the smallest amount current, I hope, is flowing through C. It's a little tricky question. Without calculation, we are getting the answer totally conceptually on the concept base. So C is the option for question number 31. Okay. So here we go. It's a big question. Let me show you. Yeah. The diagram shows a wire placed between two magnetic poles of equal strength. A current passes through the wire in the direction shown. The current causes a downward force on the wire. We call this motor effect. What is the arrangement of the magnetic poles? Okay, so you apply the left hand rule. So stretch, you take your left hand, stretch your fingers, thumb, index finger, middle finger, in such a way that they are perpendicular to each other. You can see they are perpendicular to each other. FMC, force, magnetic field and current. The current is coming towards me, but the force is downward. So I have to twist my hand. No. So see, the force is downward. Current is coming in this way. The magnetic field is in that direction. So it means here we have north and here we have south. So for question number 32A is the option. So try this, try the left hand rule. You have to twist your arm. Okay. So try it and you will be able to tell the direction of the magnetic field. So direction of the magnetic field, if the direction of the magnetic field is in this way, it means north is here and south is here. So the A is the option. Question number 32A is the option. Okay, again on your screen. Question number 33 is on your screen. The diagram shows the output of an AC generator. The coil in the generator shows 20 times in 1 second. Okay. The speed of rotation of the coil steadily increases. Which graph best shows how the output changes? You know, if you will gradually increase the speed of the generator, the voltage will increase and the frequency of the EMF generated will increase. So what will be the effect on the graphs which are shown here? So when you will gradually increase the speed of the generator, the amplitude of these graphs should gradually increase. The amplitude is from mean position how high you go, or from mean position how low you go. So gradually, if this was going this, then it will go like this, then it will go like this. Gradually, the amplitude of the graph should increase. Plus, gradually, there should be more number of waves shown on the display. So if you look at carefully, this is the original, and these are the options, and the D is clearly the option. Gradually the amplitude has increased, and gradually there are more number of waves shown on the same screen, on the same CRO screen. More number of waves are shown. So D is the option. So for question number 33, D is the option. I hope you are able to understand it. Okay, let me increase the size. Okay, D. On your screen, we have question number 34, which is on your screen right now. It says that there is a bright spot on the screen of a cathode ray oscilloscope. This is caused by fast-moving particles. What are those? These in the CRO, the particles which are emitted by the hot filament, they are electrons. They are electrons. So for 34B is the option. For 34B is the option. Okay, on your screen, thermistor and light dependent resistors are connected in series. Which condition give the largest resistance? As you see, the thermistor and the LDR, light dependent resistor, they are connected in series, and we want the largest resistance. The resistance of the thermistor can be increased if it is put in a cold place, and the resistance of the LDR, the resistance of the LDR can be increased if it is placed in a dark place. So the condition should be dark and cold, or cold and dark. In the cold, the thermistor will have high resistance, and in the dark, the LDR will have high resistance. So because they are connected in series, so the whole thing will have high resistance. So for 35, A looks the option, cold and dark. I hope this is clear. Okay, sir. Question number 36 is on your screen. 3 types of radiations emitted by unstable nuclei are helium nuclei, short wavelength electromagnetic waves, and electrons. What are these 3 types of radiation? Helium nuclei is called alpha particles. Electromagnetic waves are called gamma rays, and the electron emitted are called beta. So A looks the option. Question number 36, A is the right option. Question number 37 is on your screen. Which row is correct for nuclear fission and for nuclear fusion? In nuclear fission, what we do, we have, suppose, a nucleus of, let's say, uranium, large nucleus, and you bombard it with neutrons. And what happened? That now large nucleus breaks and produces 2 daughter nuclei, which are smaller. So a large nuclei break into smaller nuclei in the nuclear fission. It produces smaller nuclei. But in the fusion, the opposite happens. 2 small hydrogen nuclei, for example, they come together, they fuse with each other, and they make a large nucleus of helium. This process is called fusion, and a lot of energy is produced in it. And this is happening on the sun, and it is happening on the other stars. So this is the energy source of other stars. So the option given here, the correct option is C. Fusion produces smaller nuclei, and the fusion is the energy source of a star or sun. So C is the option for question number 37. Okay, on your screen, you can see question number 38. Which graph shows how the count rate of a radioactive isotope with time? The count rate, if you have seen the graphs of half-life, you should remember that the graphs are like this. The count rate graph changes like this. So A is the option. If you have read your textbook, radioactivity. And if you go and read the topic half-life, you will see all the graphs of the count rates are like this. With the passage of time, they are decreasing, but they are decreasing like this. So A for 38A is the option. On your screen, we have question number 39. For which purpose is the radioactive isotope carbon-14 used? You must have heard the word carbon dating. Yes, it is used to find out the age of different ancient bones. So for which purpose is the radioactive isotope carbon used? Is used for dating of ancient bones. A is the option. Question number 39, A is the option. Okay, sir, we have question number 40 on your screen. A nucleus of phosphorus P1532 emits a beta particle to form a new nucleus. What is the nucleon number and what is the proton number of the new nucleus? You know, whenever a beta decay happens, when a beta particle is given out, the daughter nucleus which is produced, that daughter nucleus will have the same nucleon number, but its proton number will be one more and its neutron number will be one less. So remember these three things. When the beta decay happens, the daughter nucleus as compared to the parent nucleus, its proton number will be one more, its nucleon number will change.